Okay, so this is on page 15 and it's number 2E. Did I press record? Yes, I did. Okay, good. So we need to find the mass of magnesium consumed in 5 minutes. So this is a conversion type problem, and usually when you have a conversion type problem, you will have find the mass of magnesium. So that is our unknown, right? That's what we need to find. And usually in a question, when we are given an unknown and we need to do some conversions, the unknown is directly connected in the sentence with the initial quantity, what you're going to start with to convert. So what is find the mass of magnesium connected to? Chat with your neighbor about that. What is find the mass of magnesium connected to?
Well, we use the formula rate of the mass over time, so we can go from.
What is find the mass of magnesium connected to in the sentence? Time, yeah. Consumed in 5 minutes. So what we want to do is we want to take 5 minutes and we want to eventually convert that into the mass of magnesium. And what is the unit of mass? Grams. So we want to get to grams. Do we have any conversion factors that directly relate minutes to grams? No. But what could we convert minutes into?
Second.
We could convert 5 minutes into seconds. And can we convert seconds into grams? Do we have anything that converts that?
Grams per second per second.
Do we have grams per second anywhere?
No, we have moles per second.
But we could find grams per second if we wanted to, or even more easy than that, you could convert from seconds to moles. And if you now have moles, could you find grams? Yes. Okay, so you would say, okay, I have my 5.0 moles, or sorry, minutes, and I want to convert in 1, 2, 3 steps. So I'm going to have 1, 2, 3 conversion factors. In my first conversion factor, I want to cancel out. What do I want to cancel in the first conversion factor? Minutes. And we're trying to find seconds, so seconds go on the top. In the second conversion factor, we want to cancel out seconds and find moles. And in the third conversion factor, we want to cancel out moles, so moles go on the bottom and we need to find grams. So we know a conversion factor between seconds and minutes, that's 60 seconds per 1 minute. We know a conversion factor between seconds and moles because we are given it in the question. That is 5.0 times 10 to the negative 9 moles per 1 second. And the molar mass of magnesium, I think it's 24.1, 24.3. 24.3 grams per mole. And so we do that calculation and we get whatever the heck it is we get at the end, 5 times 60 times 5e negative 9 times 24.3 equals 3.645 times 10 to the negative 5. What would we need to then do with that answer? Pardon me?
It's going to be just 3.6.
It's just going to be 3.6 because we need to have 2 sig figs. 3.6 times 10 to the negative 5. Are we done?
No.
Nope. What are we missing?
What over grams?
We are looking for grams. And if you look at all your units, they cancel out and they give you
How does
grams.
minute cancel out?
Minutes canceled out here.
Oh,
Okay, so what you'll see is as you go along, the minutes cancel with the minutes, the seconds cancel with the seconds, the moles cancel with the moles. So it kind of goes like up, down, up, down, up, down, all the way along. And if you're really doing your job, what will you do with your answer once you got it there? You will put it in a box because that will be kind so I can see what your answer is. Just a good habit to be in. All right. Any other questions? Yes. C, D. Okay. So we have the rate of consumption of magnesium in moles per second. So we have 5.0 times 10 to the negative 9 moles per second. I'm going to rewrite it like that so the conversion is easier. And that's moles of magnesium per second. And we want to convert that into liters of H2 per second. Now, this is the only time in grade 12 when you will need to use the fact that a gas at STP has a volume of 22.4 liters per mole. And I believe at the top of the question, does it say at STP? It does not, but we're going to make that assumption. At STP.
with consumption rate and production rate, the same thing.
Consumption is when you use up a reactant. Production is when you make a product.
Oh,
So you would say consumption when you're talking about a reactant. You would say production when you're talking about a product. Okay? Can we go from moles of magnesium directly to liters of H2? Is that possible? No. What would we have to do? We would have to go from moles of magnesium to what first?
correct. Oh, yeah.
Would grams of magnesium get me closer to, can I go from grams of magnesium to liters of hydrogen? Is that easier? No. So let's not do that. Let's not go further away from that. How do I convert from one substance to a different substance? What do I need to use?
Proportion.
I need to use the proportions from the balanced equation, and that always has to be moles. Okay? So when in doubt, convert to moles. When in doubt, convert to moles. When in doubt, convert to moles. Okay. So we're going to go from moles of magnesium to moles of hydrogen. And from moles of hydrogen, we can use that conversion factor to go to liters of hydrogen gas. So we would have then 5.0 times 10 to the negative 9 moles of magnesium per second times, and then we would need to cancel moles of magnesium and find moles of hydrogen. Once we've gotten to moles of hydrogen, we need to convert that into liters of hydrogen. So we need to cancel liters of hydrogen, moles of hydrogen, and find liters of hydrogen. So you would need a balanced reaction for this in order to have the coefficients for your mole ratio. So we would have Mg plus HCl goes to MgCl2 plus H2. I'm not bothering with my states because we're just doing this very quickly, but we would have 1 magnesium for every 1 H2. So that's a 1-to-1 ratio. And there are 22.4 liters for every 1 mole of gas. So 5e negative 9 times 22.4 equals 1.12 times 10 to the negative 7. Are we done? No. What would that have to become? 1.1 times 10 to the negative 7. Are we done? No. What would it have to say?
Liters of hydrogen.
Liters of H2. Are we done? No. We're going to put it into a
What?
box because we're done. Because we are done. Oh, per second. Whoops. Yes. You don't have to do this as long as they're all there. Do you know what I mean? You have to show your units. Okay? Every number in chemistry needs a unit. If your number does not have a unit, you will lose marks. Okay? It's as much for your own good as it is for mine, because when you don't show units, you tend to make mistakes. Now, when we get to unit 2, you'll be all excited because we all of a sudden throw units out the window because there is a unitless quantity called the equilibrium constant. And you'll be like, I don't have to show units, yay! But until then, units everywhere, okay? Every number needs a unit. Anything else? Okay. Last day, we were looking at the example on page 11, and we hadn't quite finished it. So I know some of you have finished it, but let's go over it just to be sure. We had an initial mass of zinc of 2.45 grams of zinc. That's given in the question. And we are told that there is 1.01 grams of zinc remaining after the time was up. And this is on page 11 if you missed that, page 11. So our final mass is 1.01 grams of zinc. So if we are asked to find the rate in moles of zinc used per minute, is the moles of zinc used A, 2.45 grams? Is it B, 1.01 grams? Or is it C, something else? Grams of zinc is? C, something else. Because how would you find the not the moles used. How would you find the mass used?
Subtract.
Just subtract the two. Absolutely. Okay. So we would say the mass of zinc used equals. Do you need to write this? Should you show me what you're calculating? Yes. Show me what you're calculating. Yep, you'll get marks off.
Wait, what happens when the just write rate? Does that work?
You can do that. I'll show you how to do that in just a moment. Okay? Yeah. But we're going to do it separately here just for the moment because that's what I'm doing right this second. So we got 2.45 grams of zinc minus 1.01 grams of zinc. And if you are not wanting to write out your units for every single number like that, you could also do it like this. Minus 1.01, you could put that whole thing in brackets and say grams of zinc. Yes, then that grams applies to both the numbers in the brackets. Okay? And we get 2.45 minus 1.01 is 1.44 grams of zinc. So that's the mass of zinc used. And we want our rate equals the change in moles of zinc over the change in time. And we're going to start with 1.44 grams of zinc per time. And our time is 2 minutes. But we don't want grams per minute, we want moles per minute. So we're going to cancel our grams and we're going to find our moles. And that is it 65.4? 65.4. You would think after 30 years teaching this, I would know the molar mass of zinc, but not always. 1.44 divided by 2 divided by 65.4 is 0.011009. What's our unit? So our grams cancel out, right? Grams cancel out. Yeah, what we've got left is moles per minute, so that's moles per minute. But before I write moles per minute, I'm going to be a little bit lazy, and I'm going to do my rounding first. How many sig figs should be in that number? 3. So that's going to be 0. Tell your partner. Tell your partner, what should that number be? We want 3 sig figs.
One something else. 110. Yeah, 110.
Is that correct?
No, but that's 3 sig figs though.
That's not 3 sig figs, is it? How many sig figs is that?
2.
2 sig figs. Okay, so we need to have that third one there, and then we will have our units, moles per minute, put a box around it, and you're all done. Is good? Okay. We're going to try the example on the next page, which has a table of data so that you get used to working with tables because you'll sometimes see those. So first of all, a chemist wishes to determine the rate of reaction of zinc with hydrochloric acid. Please write the balanced formula equation for that reaction. So this is on page 12. See if you can include the states as well.
So all of the metals should be solid except for
Metals should all be solid except mercury. Yeah.
It feels like gas. Wait, is that acid? So is it gas? I mean, what acid is usually
Yes,
and okay, liquid is just zero water. Like in like liquefied form, there's nothing here. Liquefied form. It's just like mixed with other things. So I think it's aqueous. Oh, yeah, right. H2 is a gas. And where's the end? I think it's like somewhere there. Okay, so it's right? Yeah. Now we gotta use solubility at Mario. Then it's CnCl. Two, because yeah, zinc is +2. Yeah, +1. -1. Yeah. Okay, so it's just balance this. This 0 and 2 HCl. So it is a aqueous. Wait, yeah, it's an aqueous. It should be like this, or it's cellular. So yeah, on the bottom. I need to back the completion.
Yes.
Okay, most of the part about this, I see the same thing as the food. Yeah. Acids. H2's a gas, right? Like I'm not stupid. H2. Yeah. I was looking at
What state now? Absents are always aqueous.
you'll want
Folks,
this.
absents are always aqueous. Okay, absents are always aqueous.
You think you want to make her look at the yes. Yeah, that's what we wanted to do.
Yes.
These are pretty good.
Yeah, so
It's
it's.
kind of
And hydrochloric.
You just gotta like look into yourself, look into your hand or something. Like oh that's not
Yeah, so it's just.
straight leg, whatever letters numbers.
yeah.
Maybe have like like you know those things where people have like pouches, like connect to their mouth to make because they don't have like a front.
What is that? Do people actually wait?
Yeah.
Oh, shoot.
Kind of a front.
Okay.
Just have like a little one of those so you can look and see how it works. So you can cheat on tests.
The only one in charge is a. Because how to charge.
Yeah, it's like that. Yeah. Having it like slot through a tube directly because it's not.
Which is. And let's take the reaction. Same word, so somebody's on this place summary.
I feel like the average, so it's just like
It just rise over, right?
yeah, so it should be 0.006 minus 0.0.
Yeah, it goes down constantly, so just be like. Rise, over, rise, so 0. 0. Green.
Because the sink is by itself.
0.0.
It's gonna look rocky.
No way, right? That does not make sense. Actually, I'll be trusting because
If
Wait,
it's,
times 4?
so if you have metal solid.
wait, what do you get time for?
Wait, that doesn't make I think what it wants you to do is average rate of reaction. I think it wants you to add all of these
Because
together
in order to become positive.
and find the average.
It's
So,
on its own.
yeah.
Then no one's gonna do.
It's literally
Yes.
negative.
And that's like a solid there. And it's not. Okay. Oh,
Okay, let me try this one.
Yes. Yeah.
Yeah, I don't need more.
So if you were to put this on a test.
I just tried adding everything together
That's not how it works.
and then dividing it by 6.
Where do you get 6 from?
That's how many things are. You add it together. Then you divide those. Average by average.
No, that's not how it works. You have to use the rate reaction, average rate of reaction, not how much.
So average throughout the whole thing.
No, that's not how it works. Use the formula. I do not know.
I have to acid probably for 2 months. Just like a little one.
No, it's small. By itself.
I don't know where to find it. No, no, it's like the answer. It's just the answer. Not one page. Like multiple pages. Oh, I did get it right. Yay. I am so smart. I am so smart. So, you know
I haven't checked everyone's, but I want to go through the things that I saw as I was going around very frequently. First of all, what type of reaction do you have when you have an element and a compound? That is single replacement. If you didn't know what HCl is, or sorry, what that hydrochloric acid is HCl, it is one of the acids that's super common. You probably should know it, but if you forget, on page 6 of your data booklet, there is a list of acids. Okay, so if you need to look up an acid, there is a list in your pink booklet. Secondly, let's pretend this is zinc. I know it's actually iron, but let's pretend this is zinc. A lot of people had zinc written as aqueous. Is this aqueous? No, it is solid. Anytime you have a metal, metals are always solid. You should know that, okay? Gotta know it. Metals are solid. Acids are always aqueous. Okay, you should also know that. Acids always aqueous. Now you have to decide, who is zinc going to replace? Will zinc, oh, and before we do that, what is the charge of zinc here?
like +2.
Is this zinc or is it zinc with something else?
Just think by there.
It's just zinc by itself. And if it is just zinc by itself, how does zinc become 2 positive? What does it have to do with its electrons? It would have to give its electrons away. If it is by itself, who did it give its electrons to?
No one.
Nobody. So what is its charge? No charge. Elements on their own have no charge. Now, when you separate ions for a complete ionic equation, those are still part of a compound, so they can have charges. So complete ionic equations, you will have H plus Cl minus, but it's really part of HCl. Okay, so there's no charge on the zinc. But if zinc were to have a charge, what would it be? It would be 2 plus. If you forget that, in your data booklet on page 3, there are charges of common ions, and you can look up that zinc is 2 plus. Okay, so anytime you forget any of the charges, they are on page 3. It's really good to know them by heart, so you don't always have to look them up, but, you know, do what you can. All right, so we've got zinc, HCl. So that is going to then become, zinc would be a 2 plus ion when it becomes an ion. Hydrogen is H plus, chloride is Cl minus. Who is zinc going to pair up with? Is it going to pair up with hydrogen or is it going to pair up with chloride? chloride because positive goes with negative. How do you know that it is ClZn or Zn before Cl? Which one? How do you know?
It was always zinc chloride. It was always like
It's
that.
always zinc chloride. The metal always comes first. Whatever is on the left of the periodic table comes before the thing that is on the right of the periodic table, okay? So in your formula, zinc chloride, on the periodic table, zinc chloride. All right? Positive ion always comes first, negative ion always comes second. Now, what if I write ZnCl? Are we good with that? No, why?
It should be zinc Cl2.
Zinc has a 2+ charge, so we need to have 2 chlorides to match with that. What state will that be? It's going to be aqueous. All right, and hydrogen has now been kicked out. Is it H+?
Well, it is, but it's not like that. It should be 2.
It's not H+.
It's just H2.
It was H+,
That was H2.
but it grabbed some electrons from neutral zinc. So neutral zinc came along, it gave an electron to hydrogen. So an electron went to one hydrogen, and another electron went to another hydrogen. That left zinc with a 2+ charge, and the hydrogen became neutral. But hydrogen is one of the diatomics, so it has to be H2, and that is a gas. Okay. Now we're going to calculate the average rate. If we're calculating the average, where do we start? Where do we finish? Start at the beginning, finish at the end. And we want grams per second. Oh, that's convenient. Yes. Oh, I forgot to balance it. You're absolutely correct. I did. I have a habit of doing that. There we go. That'll be better. Yes. Thank you very much. Anytime I make mistakes, please do feel free to correct me because I make them all the time. And you don't want to have incorrect information. Do you have to write this formula?
No.
Yes.
What? I could just write like just 5.0. That's it because it's from
Yes. And then you're going to plug in. Do we go initial minus final or final minus initial? Final minus initial. Okay, so our mass and then our seconds.
Like I like the teach like how to kind of like write down examples. So I just like write down all the units like oh this equals to this after I go.
Question. How many sig figs should be in the grams here? We've just done, we've subtracted, we've taken that number and we've subtracted that number.
How many six figs should it be?
Yeah.
It should be 2. 1.
When we do a subtraction, you round to the first uncertain digit. So who is our uncertain digit in 0.006? The 6. So that is in the 0.001 position. Yes, the thousandths position. In 0.016, what position is our uncertain digit? 0.001, 0.001. That is our uncertain digit. That means that our uncertain digit in the answer is in the 0.00. Oh, and I've done this wrong. My math is wrong here, sorry. So I would have to have that there. I saw your face. You were like, what's she doing? She's done it wrong. I see people's faces and I'm like, oh no, I've done something wrong. Ah, okay. So our uncertain digit is here. That means we have 2 sig figs and 2 sig figs. And so, who are you looking for? You found him. Okay, good. All right, and so we do that, we get 0.01 divided by 20, and we get 5 times 10 to the negative 4 units,
We should never write the negative at the
grams per second. I forget the negative all the time. I actually had a math teacher in grade 11 who on my final exam did not take off marks for me missing my negative signs because I did it all through the course, and he felt kind of bad for me. So I will forget them all the time. Thank you for catching me and pointing them out. Okay, now, is this a correct answer? No, what does it need? It needs sig figs, 5.0, put a box around it, and you are done. Yes? So that's what you would do if you have, a table of data. Now, what if I asked you for the average rate between 4 seconds and 12 seconds?
the same thing, so like, yeah.
So you would just use the values at 4 seconds and 12 seconds instead of at the beginning and the end. Do we need to go through it or are we okay? We're okay? All right, good stuff. This is just a conversion between units. Do we need to see that where we have our grams per second? Could we convert it to moles per second? Yes, we don't need to do that? Okay. Blah, 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 blah. We're going to skip that. We're going to skip that because we've done a bunch of that stuff. There's a bunch of exercises here that I'm going to let you do at home or at the end of class today. All right. And in the meantime, we are going to go on to 1.1c, which is actually a little bit of review of yesterday. This is on page 18. How to measure rates in the lab. I'll be sure to put that in your report card comment. Yeah, anytime. So none of this should be particularly new, but this just kind of formalizes it. You have to pick a measurable quantity. So if you have a solid in your equation, what's a measurable quantity that you could use? Mass. If you have a gas, what's a measurable quantity you could use? Volume, pressure, and mass of the system. Okay, what if you have an aqueous substance? Concentration, okay? But concentration is usually a poor choice because it's hard to measure, yes? 2 exceptions to that. One is, so this first one is aqueous. 2 exceptions is when you have hydrogen ion or hydroxide ion. That is easy to measure using a pH meter. Yes, we talked about that yesterday. Also, if you have a colored species, You can use a thing called a spectrophotometer or a colorimeter. You do not need to know those names. You just need to know that there are devices that can measure changes in the amount of color. Okay, they shine light through it, and the more that light gets absorbed, then the darker the color is and the higher the concentration. Okay, how are you going to know that something's colored? It will say in the question. Okay, so it's going to be like Cu2 plus, and underneath it'll say blue. Yes? All right, so you'll see it. You'll be like, oh, it's a colored species. That would be a good thing to choose. All right? Gases, like we said, you can do pressure or volume or mass of the system, mass of a particular solid. Theoretically, you could do a change in temperature, but yeah. All right, I don't think we need to go through this because I feel like this is just too much. However, on page 19, I would like you to tell me where is the rate the fastest and where is the rate the slowest. Tell your neighbor, where is the rate the fastest? Where is the rate the slowest?
At least find the equation of the graph. Find the equation of the graph.
I've taken like health in the year.
Okay, are we ready? And remember, you can say pass if you don't want to talk to me. It's okay. All right. At what point is the rate the fastest? Not in this class anymore. James.
I'll do it.
Yep.
Is the fastest point is 0 seconds to 100 seconds?
Okay. I'm gonna get you to go more specific than that. At what exact time?
0 seconds.
0 seconds. Okay, it's fastest at 0 seconds. At what time is it the slowest? Eric? Sorry? Yeah, at 600 seconds. I would like, just before we go on, basically what we've got is we have a solution of SO2Cl2. Okay, and as time goes on, we use it up. Yes? So the question then is, why does the rate get slower as time goes on?
We answered this in the work.
Because there's less SO2Cl2.
Because there's less SO2Cl2. And if you have less of something, you're going to have, we'll talk more about this later, we'll have fewer collisions between those particles. And if you have fewer collisions, you will have less reaction. Okay, excellent. We're going to skip how to do a titration. We don't care. pH meter, we already talked about what a pH is. The only thing that you should take away from this page, and so we're going to box it, is that a lower pH is a higher acidity. So if you have a lower pH, you have a higher hydrogen ion concentration. They are opposite of one another. Okay, H plus and pH are the opposite of one another. If one is bigger, the other is smaller. If one is smaller, the other is bigger. Okay, and there will be some questions in this unit where they're like, will this result in a higher pH or a lower pH? And you should be able to say, higher pH. So if I go from pH 4 to pH 7, what has happened to our hydrogen ion concentration? Has it increased or decreased? H plus has
Become more base-like, I think.
decreased. If pH increases, hydrogen decreases. Okay?
Wait, so the most
Oh.
acidic would be like 1.
The most acidic is 1. Okay? Well, actually, it's 0. So we go from 0 to 14, although you can actually go above and below, but not very often. Okay, so we're going to say for this point in time, pH of 0 is the lowest concentration of, or sorry, is the highest concentration of hydrogen.
At 7 it's just water.
At 7, it's neutral water. And at 14, that is our lowest concentration of H plus. So down here, these are acidic. These are basic. Anything above 7 is basic. Anything below 7 is acidic. You guys remember learning that in grade 10? Yeah? Okay. Okay. pH is only going to work if you have an acid or a base. So if we have a reaction where we have aluminum plus hydrochloric acid gives AlCl3 plus H2, if we write our complete ionic equation, the hydrogen is there, and so you can use a pH meter.
Oh, since the hydrogen is there.
Yeah, if you have H plus ion in your equation, you can use a pH meter.
Oh, but how do we know the pH meter?
How do you know that you can use it?
No, how do you like get the pH meter?
You say, Miss Spence, can I have a pH meter, please? Yes? It's a piece of lab equipment.
Oh.
Yes?
No, like, oh, I thought you mean like, how do we use it in the equation? But like,
Oh, no, you don't use a pH meter in equation. It means you can use a pH meter to measure rate. Sorry, I should have been more clear on that. Yes? Does that make more sense now? Very good. Okay. So that's a pH meter. Don't worry about the details on this page. You don't really need to know the name spectrophotometer. You don't need to know about a calibration curve. I have this in there because I use the same workbook for Chemistry 12 and Chemistry 12 AP, and they have a whole section on spectrophotometry. So we're just going to skip over this, but you should recognize that if you have something like this, so we're now on page 23, if you see that you have a blood red species, you can measure the concentration And because you're not responsible for knowing the name, you can just think of it as a color measurer. Okay, if you are interested in knowing the actual name, it's actually either called a colorimeter or a spectrophotometer. Colorimeters only measure one color of light. So it's like if you have copper, you can use a copper color colorimeter. A spectrophotometer will work for all different colors. You can set the wavelength to different things, okay? So if you are asked, how could I measure the rate of this reaction? So you can find the rate by measuring the concentration of colored species. Is good? And that's all you really need to know about that. Okay? So all the rest of that is just blah, 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 blah. All right? You can measure a change in conductivity. What sorts of things conduct electricity?
Copper, aluminum,
Yeah, we have metals, but
water.
we are mostly concerned about measuring conductivity in aqueous solution. And let's remember, electricity, the flow of electricity is the flow of charged particles. In solution, who are the charged particles? Chat with your neighbor about that. Who are the charged particles in a solution?
And which one? The one on top.
Any solution.
With
If we have a solution that contains charged particles, what are the charged particles?
the non-metal, right? Because they're yeah. It's probably not really a charge.
Yeah. Yeah, you can only be right. Right? Yeah. Yeah.
But isn't a positive charge a good charge? When it's an aqueous, there's charges. There's five. Oh, no. When it's a compound. No.
I feel like the aqueous tends to be the like charged stuff.
When it's a
The
covalent,
non-metal.
when it's a compound, it's charged. It's not a compound. It's singular.
Not, by the way, not every solution has charged particles. Okay, just to be clear, not every single solution has charged particles. If I dissolve sugar in water, there are no charged particles. It will not conduct electricity. Sugar water does not conduct electricity. Salt water does conduct electricity. Anyone want to give it a try? What might it be?
Was it? Is it on the paper somewhere?
Yes, it's on the paper somewhere. Yeah. Ions. Yes? Okay. So in solution, if it will conduct electricity, you will have ions. So if we have a reaction that looks like this one, where we start with some positive ions and we finish with some positive ions, and we have some negative ions, and we finish with some negative ions. How many ions are there in the reactants? Count them up. How many ions in the reactants? Not 4.
2.
2 plus 2 is 4. 4 plus 1 is 7. Oh, yeah.
2 plus 2 is 4, plus 1 is 3, plus 2 is
Oh,
7. Yes?
Yeah.
Are we good with that? So there are 7 ions in the reactants.
And then
How many ions in the products?
4.
4.
What is it?
Do you think conductivity is going to increase or decrease as time goes on, as we move from reactants to products?
Decrease.
Conductivity is going to decrease as the number of ions decreases. And if you're wondering what the heck this little thing is, that says SOLN, and that stands for solution. Okay? I am big on abbreviations because I'm lazy. I like to write fast.
Or the multiple abbreviation to take down notes with back in the day.
And we're not going to spend too much time talking about the methods when a gas is produced because we talked about it yesterday. But do you remember what equipment we could use to measure volume of a gas?
No,
We can use a barometer would not measure volume, it would measure the pressure. Yes. Yes. Why is the reaction what? Sorry? Why is it 7 ions? We have 2 Ks. So that's 2. We have 2 Is. So that's 4. We have 1 lead. That's 5. And then we have 2 NO3s. Yeah, so anything that has a charge is an ion, and you have to include the coefficients when you're counting them up. Did that make sense? Yeah, thank you for asking for clarification. I appreciate that. Why is the product 4? Because we have 2 K pluses, we have 2 NO3 minuses, but the lead and the iodide, although they are still ions, they are stuck together so they're not freely moving. So they cannot conduct electricity. They're like sitting in a little chunk at the bottom of the container. Yeah? Good stuff. I like that you guys ask questions. That makes me happy. Anytime you don't understand something, please ask, because that is the way that you learn, right? If you just sit there puzzled and you're like, I'm too shy, right? It means you're not getting the full experience. It means you're not getting your money's worth out of me. Your parents pay my salary, right? Well, I also pay my salary, but your parents pay my salary. You should be getting your money's worth out of me. If you have a question, you should be asking me. You should be like, hey, we paid for this. I would like an answer, please. Okay. Now, if you have a gas, it only works if you have a change in the number of moles of gas molecules. So, if I had a reaction like this, H2 plus I2 gives 2HI, and those are all gases. How many gas molecules in the reactants? And remember, MC for me means molecules. How many gas molecules in the reactants? Chat with your neighbor, and then we're going to vote.
Look at the coefficients. Well, like if H2 is together by the coefficient.
Right.
So it doesn't make sense. I think it's more next to it. No, doesn't make sense. No, doesn't make sense. Makes sense.
There's the change.
Yes. In this case, we're going to call it gas. We're just going to up the temperature a little bit. Okay? You're right, it is a solid, but we're going to go with gas for now. Okay? We'll just up the temperature. So, you're going to show me fingers. How many gas molecules are there in the reactants? And if you don't know, it's okay to say, I don't know yet. I got 4, I got 2s, I got 4s and 2s. Anyone want anything other than a 4 or a 2? Not yet. Okay. So what we've got is we got an H2, which looks like this.
Oh, so it's 4.
So that is one particle because they are bonded together. So that's one molecule. Okay. I2, those are bonded together. So that's one molecule. So that's 2 molecules. How many gas molecules are there in the products? We're going to vote on this as well. Have a little chat.
Air bonded. It's 2. Obviously,
Sometimes I just do that.
Yeah, you're really
Yeah.
good at it though.
you are.
How many gas molecules? 5, 4, 3, 2, vote. We got 2s, we got 2s, we got 2s. Yeah, they're 2 because each HI is one molecule, but we have 2 of them. So there are 2 gas molecules. Would there be any change in volume if we take 2 molecules and we change them into 2 molecules? No change in volume. Would there be any change in pressure?
Maybe.
No. It doesn't matter what gas you have, volume and pressure are unaffected by the type of gas.
Oh, it's all.
Okay? Yeah. So if you see a reaction where you have gases, don't always assume that you can just measure pressure or volume. You actually have to start with more gas and finish with less gas, or start with less gas and finish with more gas. Okay? This is just a picture of a pressure gauge. You don't need to know what that looks like. You just have to be like, pressure gauge, I can measure pressure. Yeah, last day we talked about the gas collection tube. If you want the big fancy name for it, it's called a eudiometer, but you don't need to know that either, okay? You don't need to be able to draw this apparatus. You just need to be able to look at it and go, ah, I am collecting a gas. I am measuring the volume of the gas, yeah? So if you were given a picture like this, you'd be, ah, I'm measuring how much volume of gas is produced. And change of mass of a system, you would just put everything onto a balance. This one, because it is so simple, you should be able to describe this one. Yes? So if you have something where a gas is being produced or like here we have 85 gas molecules in the reactants, and we have 114 gas molecules in the products. Will there be a change in the mass of the system as time goes on? Yes. Okay. Yeah. Okay. I think we're done. Yes. Okay. So what you're going to do for homework is you are going to do page 26 and page
Wait, all the chemistry students combined for all the units was $5.
Yes.
Yeah. So my mom doesn't pay for extra free transport.
Now, if you have extra time, that's kind of like your minimum. If you have extra time, you might take a look at page 17 and 27. Yes? No, these are all in the green book. And why might you be wanting to do that? Because I would like to have a quiz on section 1.1.
Friday.
Not Friday, that's tomorrow.
Oh, that is.
But I was thinking Monday. Is that fair enough?
1.1 entirely.
Yep.
Not even that fast.
Okay, so we will have a quiz on section 1.1 on Monday. So you should be doing these kinds of questions, to make sure that you are good so you can ask questions tomorrow. So like I said, if you have a little extra time, do the extra questions so you feel good about it. Yeah. Alrighty?
2 pages of answers.
We can't answer, but don't look at them until like I
That's the smart thing to do.
I've done everything so far except for like 1 point. Oh yeah, no, never mind. Number 6, page 6, number 3. Not even. Yeah.
Beta's here, Evan's here. No,
Oh, yeah.
not Evan, Owen. Fiona's here, Kia's here, Claire's here, Owen's here, Alexander's here, Josh is here, Gianna's here, Taryn's here, Kaita's here. Hi. Yes. Isabella is here. Nicole is here. Chloe's here. Eric's here. James is here. Zoe's here. Tree's here. Alex is. Alex is away today, hey? Beside you? Yeah.
He was talking about like the perfect page of
Ronia's here. Romina is here.
literally, like, it was like
Amir has transferred out. Matthew is here. Noah's here. Sambit's here. Nathan is here. Jade's here. Celia is here. Popro's here. And Bella is here. Yay. You may go get your phones.
Yay. I think last month I was like, frankly, like you get extended from academic and then like frankly out of nowhere I was like, oh, let's study.